Hey guys, welcome back. In this course we're going to optimize the shape of 4 building masses, so ideally all of them enjoy great views. Great views usually means that the client has a higher return on his investment because the value of a square meter is higher. Of course there are more factors at play to determine this, but for now let's focus on the quality of the views. We're going to use Galapagos, an evolutionary solver, to do this. Galapagos comes standard within Grasshopper, so you don't have to worry about installing any additional plugins for this course. You just need the latest version of Grasshopper and Rhino. So let's start by firing up Grasshopper. In the first Grasshopper file, I've already set up some things to get us started, and let me just walk you quickly through those things. There are 3 things. The first one is our plot outlines, so let me go to Rhino and go to Perspective. And let me turn on the plot outlines. So those are 4 polylines, and those are going to be our 4 plots we're going to use for our building masses. Now the second one is the 3D context, which is a set of B-reps. I internalize the data in Grasshopper. And those are all the buildings, the surrounding context buildings that are going to obstruct the views for our 4 building masses. Now the next 2 groups, those represent the building outlines or our footprint. And I've already set up a user object that is going to generate our footprint a little bit more easy. And the last one is the rangefinder, but we're going to take a look at that when we get to Galapagos. So let me go back to our footprint generator and let me turn off our plot outlines and our context. So this is a user group with a lot of input sliders, and let me explain quickly to you what they do and why we set it up like this. So let me go to Rhino, go to top view. And as you see, we have a rectangle right now projected on our top view. And let me also turn on some dimensions, because the second group, this is just to represent some dimensions, which is the area, the size of the sides of the rectangle, and the angles. So let me turn the angles off for just a second. So right now we have a rectangle that's 50 by 30, and which has an area of 1500 square meters. Now let me go over the inputs for our outline generator. So the first one is our base point, which for now I just use the 0, base point. And the second one is the aspect ratio. And that's a slider from 0 to 1. And if I move the slider from 0 and all the way to 1, you see that the proportions changed. They go hand in hand with the cutoff bottom and the cutoff top. Those 2 variables, they represent the minimum distance or the minimum depth of our rectangle, of our footprint, and the maximum depth. So as you can see now, if I switch it all the way to 1, the aspect ratio, you see that its minimum is 14, because we specified it here. And if I switch it all the way to 0, you see that it all the way goes to 30. So the rectangle goes from 14 to 30. And that basically means that, let's say the minimum depth of our building, let's assume it's an apartment building. So the minimum depth will be 14, which means that we can have a walkway of 2 meters, which leaves us 12 meters, which means 6 meters on both sides as the depth of an apartment, which is fine. It's not that much, but it's the minimum. You can even set it lower. Let's say if you set 12, you see that right now the minimum is 12. Of course, the length switched to 125 because it still needs to match the area of 1500 square meters. But let's keep it at 14. And let's say 30, that's the maximum we want to have. And 30 is a little bit hard to put apartments because they become too deep. But let's say they serve well, for instance, an office space. And you can also change this factor, of course. Let's say you say, well, I want to use 25 meters. The aspect ratio changed, let's say. And also we can change the area to, let's say, 1,000 square meters. Nice. So let's take a look at the next two sliders, which is the trapezium L and trapezium R. Now, if I move the slider from 0.5, let's say, to 0, you see that one side became inclined. And that goes hand in hand with the max degree, which is the last slider in the group. So let me also turn off the measurements, because now we're going to take a look at the angles. We're doing this because we're setting some boundaries, because Galapagos doesn't care about the shape of the footprint. It just cares about optimizing its fitness value. And if it has to output, let's say, a shape with only a depth of 2 meters or an angle of only 1 degree, let's say, in a really extreme case, it will do so if that will result in a better fitness value. That's why right now in the beginning, we're already starting with some footprints that already are set by us. That will be usable in the end as an output from Galapagos. So the trapezium, if you set it all the way to 0, it means the maximum. You see that it has an angle on 60 degrees and 120 degrees. And that's because I set the maximum degree to be 60. Which is going to be a kind of a steep corner, but still it's usable. Because let's say if you set it to 45, you see that the corner became even more sharp. It depends on you how sharp you want the corners to be. Let's say if you say 45 is still acceptable, we can work with that. But let's set it at 60. I think that's fair enough. So whatever maximum or minimum we have, we always know that a corner will never surpass or never be below 60 degrees, let's say. And the next slider is for the other side. So it can have multiple shapes. So we can play with the shape a little bit more instead of just being a plain rectangle. As you can see, the area will always stay 1,000 square meters. And the last slider is the rotation, and that's plainly just rotating the object around its base point. I wanted to quickly show you guys what this user object does and why we set it up like that. It's to save some time, but also to explain you that Galapagos doesn't care for the shape of the building. It just cares for optimizing its fitness value. But by using this user object, we already set some maximum and minimum values for our footprint to have. So at least the results we get from Galapagos, they are within the boundaries we set, and we get results that are usable. Now, the next lesson, we're going to position these rectangles on the 4 plot outlines. So thank you for watching, and I'll see you in the next lesson.